Okay, homework 6 is posted now. I put that onto Blackboard just a few moments ago. And that's due on Monday of next week. This is another relatively small assignment. It only has 4 problems, but it's got some Excel work on it, and it's related to today's class and what we're going to be doing on Friday. And then next week, if you look at the course schedule that I provided at the beginning of the semester, we're going to have another online class on Monday. I'll be visiting another university for an accreditation visit, so I won't be here in Huntington, and we won't have our normal live class meeting on Monday. And then I'm going to keep giving you this reminder about the project. November 19th feels like it's a long ways away because it's only September right now. But it'll get here before any of us know it. It'll suddenly be November and your project will be due. So get started now. I think the project will be interesting to you because nobody is more interested than, like the most interesting subject in the world is yourself. And that's what the project's about, is about you, your career, your money, your plans. And so I hope you'll enjoy the project because it's essentially planning out some economic factors related to your work, career, retirement, and that sort of thing. So get started on the project. All right, we've already gone over the solution for the midterm exam, and we're going to start talking about internal rate of return analysis. And this content is covered in Chapter 7 of the book. And so just a renewed plug that I think it's a really great habit for understanding to read through the textbook so that you understand the concepts and get some additional perspective on the material. Has anybody here ever borrowed money from a bank before? A few people? All right. Not every bank charges the same interest rate. Some banks have higher interest rates, some banks have lower interest rates, and it changes a lot over time. And one of the interesting things is that sometimes it changes on the duration of the loan. And what this is showing is that it also changes based on whether you're buying a new car or a used car. So I took this screenshot a couple of years ago from Huntington Bank. I took the screenshot in February of 2023. And so then if you were going to be buying a car that was new or within the last couple of years, they charged 8.35%, but then older cars had a higher interest rate, and that was for a 72-month loan. I also took a screenshot on the same day of Pentagon Federal Credit Union, and they were offering a 72-month loan at 5.84%. So that's a pretty dramatic difference. You know, it was a lower interest rate. And sometimes we want to know, like, what impact is it going to have on a project if we have to pay a high rate to borrow money versus a low rate to borrow money. Some projects that are not profitable when you have to finance them with expensive money, they could be profitable if you're able to find a lender that doesn't charge you quite so much. So the revenue that comes in, how much of that revenue do you have to give to the bank as interest versus how much of that revenue do you get to keep? All of that is affected by the interest rate that you pay on the loan you're taking out. So let's say, just as an illustration, that we were interested in buying a truck and we wanted to get a nice truck. Everybody has to have the quad cab truck. The only inaccuracy is that they're not showing the tow ball sticking out like 3 feet. That's my pet peeve, is when I'm kind of walking through a parking lot and a big long truck also has the tow ball in the back, especially like some of the parking lots here on campus where it's pretty narrow. It's hard to navigate through them sometimes. But anyways, trucks are expensive. $86,645 for that one. And that's just like the starting price because dealers always have all kinds of add-ons. In addition to what they show, there's the preparation fee and the delivery fee. And sometimes they'll throw in additional profit if you're buying a car that's hard to get. So let's just take them at face value, though, and say, what if we were going to borrow $86,645? Then what would that look like if we borrowed it at the 5.84% versus if we borrowed it at the 8.35%? So in other words, what does the loan look like for those two different amounts? let's find out if it would be justified to do that if you were going to get an additional $1,500 per month in revenue. So let's just set up a spreadsheet to kind of analyze this case. I'm going to take a quick screenshot of our scenario and paste it into Excel. And then let's look at this 84-month loan, how much it's going to vary from the two different interest rates. And so we're going to have month and amount. And then we've got two different interest rates. This one is for the interest rate of, I'll just do it this way, interest rate. So there is the interest rate of 0.0584, and then there's the interest rate of 0.0835. All right, so we start at time 0. And we want to go through 84 months. So this is going to be a long one. 84 months. And then we're going to make $1,500 per month in new revenue after the cost of fuel and insurance. Let's just say that like having this truck enables us to, like start picking up additional jobs. That if you previously were driving a car and you couldn't, carry your tools, or you just weren't able to do the work for whatever reason, you're able to get an additional $1,500 per month. Let's find out what is the value of $1,500 per month. If you get $1,500 every month, I'm just going to double click here and it fills it in all the way to the bottom of that list. All right. So I'm going to find here the PV of these amounts. And so I'm going to do present value. So you don't get the revenue at time 0. It's the end of period assumption like we always do. But if you get $1,500 per month, but you're discounting at 5.84%, so PV at this 5.84%, and N, and then the future value is the negative of the revenue that's coming in. So this is going to show us the present value of that revenue over time. I know what I did wrong. I need to make this interest rate per period. This is 5.84% per year, but we've got 12 periods per year. So I'm going to say it is that 5.84% divided by 12. That's the interest rate per period. And then the 8.35% per year, divide that by 12, and now that's the interest rate per period. So let me clarify this, interest rate per period. So in this illustration, what is the total present value of all that revenue over time? So let me just up here at the top, I'm going to sum it together. So sum equals sum, and then I'm going to click here and go down. I'm pushing Shift, Control, and the down arrow, and it'll take me to the end of the row, end of the list. So Shift, Control, down, and it like naturally finds all the data. Okay, so the present value of all that money is $103,220.67. So if the truck costs $86,645, that means the difference between the revenue that's coming in and the purchase price of the truck, when you discount it at the interest rate of the loan, the difference indicates that it would be profitable. But if we do the same thing, if we do the PV of these revenues at the higher interest rate, what we're going to find out is that the story isn't quite as encouraging, because we're discounting those revenues more drastically. And so the sum is $95,170. So either way, it looks like we could cover the purchase of the truck, but we have a lot more profit if we have the lower interest rate. So should you do it? You should do it either way according to this illustration, but it's showing the impact that the higher interest rate has. So what we're going to be talking about today is the internal rate of return method. And the internal rate of return method is where you balance out the present worth of revenue and the present worth of expenses. And so we assign that variable I prime. I prime is the interest rate where there's a balance between inflows and outflows. And this is what the formula looks like. It's saying that the present worth is equal to 0 when you've got revenues and expenses, and you're discounting all of them to the present. So all of the revenues over time, like we just did, we're finding the present value of each one of those future amounts. And this is saying that there is some interest rate, I prime, the unknown interest rate, which makes the revenues and the expenses equal to each other. So in our case, the expense of the truck, it was at time 0. It's that $86,000 purchase price at time 0. So we don't really need to discount that amount. But if we discount the revenues, there's going to be a certain interest rate where it would make it anything above that, the project not profitable. So that's what the formula here is saying, is that there's a certain point where when you've got a low interest rate, the present worth is positive, but as the interest rate increases, the present worth becomes negative. And I prime, which is the internal rate of return, is that crossover point where the present worth of the revenues and the expenses is 0. They're in balance. So the internal rate of return, we can think of it a couple of different ways. We can think of it as the rate of return that's earned on the unrecovered balance of an investment. We can think of it as the rate that's being paid on the unpaid balance of borrowed money, the amount that you still owe. It's how much the bank is getting on the unpaid amount. But in this illustration I just showed you on the prior slide, it was the interest rate that brings the cash flows into equilibrium, the inflows and the outflows to a 0 balance. So the method for the internal rate of return, what you're supposed to do is, if I give you a cash flow diagram like this, discount everything to the present and do it at an interest rate where you're starting with a guess. Maybe it's 1% as your starting guess, but then you have to keep changing the interest rate until the sum of the present worths is equal to 0. So we'll look at an example of that today with our in-class exercise. So here's just another illustration to reinforce this idea of balance. Here's a scale that's in balance. The internal rate of return is the interest rate where the inflows and the outflows are equal to each other when they've been discounted to the present. So not all of the inflows and outflows are already at the present. We have to discount them, and we have to do it at some unknown interest rate, which we're constantly changing until we find out what is the interest rate that makes them equal to each other over time. So the internal rate of return is the interest rate that equates the equivalent worth of cash flows in to the equivalent worth of cash flows out. Now there's some rules. We can only calculate the internal rate of return if you've got more revenue than costs. There's no such thing as a negative internal rate of return. So it automatically is assuming that you have a return. So you can't calculate the IRR on a cost-only alternative, and you can't calculate the IRR on something where there's more outflows than inflows. There has to be more inflows than outflows to be able to calculate the internal rate of return. It's easily solved using Excel or using graphical methods. You can do it manually, but it would take lots of pages to do it manually. So we usually would use Excel. And here's the decision criteria. You already know that this phrase decision criteria is really important, because on the exam I asked you to tell me one of the decision criteria. So this is how you use the internal rate of return. If you do an analysis on a project and the internal rate of return is greater than the MAR or equal to it, then you can accept the project. But if the internal rate of return is less than the minimum attractive rate of return, that tells you you should reject the project. So if your return rate is less than what's the minimum that's acceptable, then naturally you shouldn't do the project. You should reject it. So sometimes we'll do IRR on multiple projects. If you have many alternatives, you can apply the internal rate of return on multiple projects, but you can't pick the best project based on which one has the highest IRR. That is not a valid method for choosing alternatives. So I'm giving you some warnings here. It's okay to use the internal rate of return to see if a project is acceptable, but you can't use the internal rate of return to find out which alternative is best. It's not a reliable indicator of which project is the best. And we'll do an illustration that tells you why that is. There's also an assumption with the internal rate of return. You may be wondering, like, what's internal about this rate of return? Like, what does that mean, internal rate of return? It assumes that any profits you make are reinvested into the project. So you can do that with a savings account, for example. The interest that you earn in a savings account, you can leave it in the savings account. And then the rate of return that you earn, the compound interest that you earn in a savings account, is a good example of the internal rate of return. But some projects, like if you bought a gumball machine and you set it up at a grocery store, and then you got quarters every week from that, you couldn't put a second gumball machine in the same store and expect to generate the same amount of profits with the second gumball machine. So some projects, you can't take your earnings and reinvest them into the same alternative. So this internal rate of return, when you calculate it, it assumes that the project is reinvesting the profits into the project or some project that yields the same rate of return. So those are the assumptions and limitations. Anybody have questions about those? All right, let me give you today's in-class exercise. Unfortunately, we've only got 11 minutes. Going over that exam burned through some time, but I think we can make some progress on this, working on it together at the same time. Oh, you need one more? Okay, so let's start up Excel and go through this one together, because I think it'll be a little bit quicker that way if I show you maybe a good approach for this one. All right, so open a new tab in Excel, and I'm going to paste it from here to there. All right, so for problem 1A, we want to take this cash flow diagram and find out what's the present worth if we're discounting everything at 7%. So let's define the interest rate up here at the top, 0.07, and then we're going to have year, amount, and PV of amount. We've done this lots of times before. 0, 1, 2, all the way through 8. And then the amounts, so negative 800,000, then 125, a couple of years, and then 400,000 outflow, and then 292,000 for 3 years. And then in the final year, 377,000. All right. I'm going to format that as currency just to save myself the heartbreak of seeing those annoying red cells later. All right. PV of amount. So equals PV using the 7% rate, anchor the reference to that. N is the years of the row that we're in, double comma over the payment field, and minus of the amount into the future value field. Okay, so it's no surprise that $800,000, which is already at the present, will have the present value of $800,000. And then we're going to add everything up. So equals the sum of these amounts. So this says that if this cash flow diagram is discounted at 7%, then we'd have $26,905. That's the equivalent value. So what that means is that if you were borrowing money at 7% to make that initial purchase, and then you had this cash flow sequence afterwards, so you're paying the bank their 7%, and you'd have this amount left over. This would be the present value of your leftover profits. So part B, now we want to know 8%. So here in this column, this cell, let's type in 0.08. And then we're going to have the PV of amount at the 8%. So I'm not going to type in the amounts again. I'm not going to type in the years again. But I'm just going to have this column be, what if we use 8% as the discount rate? So equals PV at this 8% rate, where N is the number of years, skip over the payment field, minus of the amount. Be careful that you don't click on the PV of amount. We don't want to find the PV of something that's already PV at a different interest rate. We want it to be the PV of the actual amounts. Okay, and then find the sum. So at 8%, this project is not profitable. If we have to borrow $800,000 at 8%, then the excess profits that are left over when they've been discounted to the present, they're negative. So it means that you'd actually be losing money on the project. All right. So that's problem one. Does anybody need to see a certain thing that I went through too quickly on this first part? I mean, for the most part, we've done present worth plenty of times, and so we're just comparing at different interest rates. One of them was positive and one of them was negative. So that follows the trend that was illustrated here. When you have a small interest rate, the present worth is positive. When you have a larger interest rate, the present worth is negative. The question is, what interest rate do we have to have so that the sum of the present worth is equal to 0? So problem 2 says, copy the cash flow table onto another spreadsheet, another tab on our spreadsheet, then use goal seek. So let's do that. Down here at the bottom, just right click and then move or copy. Let's create a copy. Here it is. So I'm going to call this problem 2. And this was problem 1. All right. So now here in problem 2, the question is, what interest rate makes this 0? So I don't need this part anymore. So I'm going to, in problem 2, the idea here is keep changing this until this is 0. So we know that if it's 8%, that goes negative. So, but what about 7.1% or 7.2% or 7.3%? You see, things are headed in the right direction, but what I really ought to do is goal seek, which is on the ribbon under Data, What If Analysis, Goal Seek, and my objective is for this target to be 0 by changing the interest rate. And so that's going to give permission, when I click OK, for it to change B1, the value in cell B1. It's going to keep changing it until that target cell is equal to 0. So the answer is the internal rate of return is 7.63%. Because, why? The interest rate that brings balance and equilibrium between the inflows and the outflows when everything's discounted to the present is defined as the internal rate of return. Okay, then in problem 3 it says use the IRR function. I don't think we've used that function before. Let's try that out. So using the IRR function, so in this cell I'm going to do equals, because we always start our equations with equals, and then type in IRR, and it'll start to give us some little hints as soon as we do the parentheses. So it just says put in the values. Okay, so let's put in all of the amounts, starting with year 0. It wants to know the full sequence of amounts. And then close parentheses. Now what it's going to do when I click enter, it's basically going to do all the calculations that I set up in this table. It's going to take every amount. It's going to assume that the first amount it sees is at year 0. The second amount it's going to assume is at year 1. And it's going to discount those amounts at some interest rate. And then when it finds the interest rate that makes everything balance out to 0, it's going to tell me what that interest rate is. So I'm going to push enter. It's at 8%, but we just need to display more digits of precision. So I go here to the ribbon under the Home tab. There's this number. And I want to increase the decimal so that it shows the same value that I'd calculated manually up above, 7.6325, etc. So that's the IRR function. All right, 149, we're out of time. When we get together on Friday, we're going to look over problem 4, which is the bond problem. However, with what we've just done today, you should be able to start on the homework assignment. If you want to jump right into that, you've got some tools to do it. So I'll see you in class on Friday. If you didn't get your exam, will you come